Okay, welcome back. This video in particular rolls up a whole bunch of things into one continuous long tutorial on installing Visual Studio Code, plus all extensions for CircuitPython, fixes a few quirks that are needed to make things work smoothly. What we're going to do is we're going to start from pure scratch doing this. So I won't assume I have anything installed. What I've done is I've created on my system a VM, and let me get my cursor to where it belongs. And there we go. So, and I'm just going to minimize these so we don't need to see them just quite yet. So, whoops. This is a bare bones KDE Neon install in VMware Player. As you can see, virtual machine up here, yada, yada, yada. I've done some life improvements to it. So I will show you what I've done. So basically you can see from this note, I made sure the full Vim was installed. Some distros only install Vim Tiny, which means certain keystrokes don't work, blah, blah, blah. I just make sure that whole thing is in there. MC is known as Midnight Commander, a Norton Commander clone. It's great when you have to move directories from point A to point B and stuff like that without worrying about command line and what it is. GUI notepad that remembers its state, like in the sense that if you ran Kate or you ran some of the others and you lost the notepad, you could lose the whatever changes you had in the files if you hadn't saved them. This doesn't do that. This is exactly like Notepad++ in Windows. It does exactly the same thing. Because at the command line, I want to see old style commands. I don't want to do IP address show and stuff like that. Net tools. And of course, I wanted a browser that I could get at my profiles for stuff. And that is Google Chrome. Now, I also got rid of the Snapd subsystem. It can get bent as far as I'm concerned. I'm a fan of, got a Debian package for it. Just bloody well installed a Debian package for it. I cannot remove Flatpak out of KDE Neon because the tool known as Discover won't let you do that. Because Discover depends on Flatpak to run properly. Otherwise, I would get rid of it too. You will need Git. Git is needed to install one of the repos and then use to get another repo. Okay. Once I had everything that I wanted, I did some checks on certain things. First, I checked my Python 3. You should be able to do this yourself. And I will just move this notepad off for a sec. So if you do Python 3, you can see right here, it's 3.810. Okay. That makes sure that. While I'm doing this, I don't want the dumb screensaver to go off and the screen locking to go off and all that other crap. So I turn all that off. I set up the desktop with the quick launch bar. You see it on the left side. It's the usual thing I always do on my KDE Neon layouts. I made sure I have a Pico ready for you guys. This guy here. And the nice thing about VMware Player is when you plug USB in, you can tell it to map that particular USB all the time to the VM. So it'll automatically do it. Get rid of this. So having all the baseline ready to go, we are going to install the Visual Studio Code and all the pieces needed. So of course, the very first thing you need is Visual Studio Code. Now, some distros, if you go to root or you sudo. I'm just going to do it by root. If you were to do, of course, apt cache search code, and of course you might want to grep for viz. There's no visual code. So all these have the two words code and visual, and then for Visual Studio Code. Some distros will have code actually in the repo. Some won't have code. So I'm working from the assumption that you don't have it in the repo. So we go off to our browser that we have open, and I go to the first tab I have set up here. Download Visual Studio Code. So we get Debian, we get RPM, KD Neon is based on Ubuntu 2004. So we need the Debian package. And we need the 64-bit package. So code 158.2, AMD 64, the Debian package. Now, one thing you want to do, and not screw around with this, is leave your home tree alone. Don't work from it. Create a place to do your work. In this case, we know it's going to put it into the downloads directory because that's the default for Chrome. Okay. Now, this is the reason why I didn't get rid of the Flatpak for Discover, is because when I click this here, Discover comes up and offers install. This is similar to GDebi, which is a GNOME Debi installer that can be attached in the OS other Ubuntus. So I'm saying here, I want to install this. Of course, it gives a password. In this case, my VM just has the classical worst password on the planet. And if you want to know what it is, you have to watch Spaceballs, the movie, and the password for the air shield, which is also the same as the password for his luggage. Yes, 1, 2, 3, 4, 5, 6. So it's installed it. Now, one bonus of this, packages like this, or Google Chrome, or anything like this, that once you install it, if you go off to etc apt sources list.d and have a look, we have Visual Studio Code as a repo now. Now, if we do an apt update, actually, first probably. There you go. Code. See? Code is now available to you as part of your repo. And you will get the updates for code consistently. So now what we want to do is make sure, as a user, we have an area to play in. So I create all the time my work directory. I leave everything else stock in the home tree. I do not try to put files in this directory. I put files into subdirectories within this tree. So I get pictures, I put in the pictures directory. I get downloads, I usually go in the downloads directory or my work directory, depending what I'm downloading, right? But I try not to contaminate this root directory. There's nothing worse in this directory if you make it cluttered. Then you can't tell stock from what you changed around. So I created the work directory. Oops. And in my case, I sucked off the host system a couple of things we're going to need to look at. This will just prevent me from cut and paste and typing a lot of silly things across the environment, which I can do if I wish to. Now, in this area, we're going to run Visual Studio Code and get it started. Now, it's in our menus. It's under development. But first thing, I want it on my quick launch bar. So I'll add it to the desktop. Now, this is a Plasma desktop thingy. Okay? You want to move that icon into this bar? You must click on it and hold your mouse. till all those dots appear like so. Now you can go like this and push onto it and let go. Voila, it's moved from the desktop, it's now in the panel. There is an option in the control panel, I won't bother showing you, but you can turn off that delay for holding the mouse button down, meaning that as soon as you click that icon, the 6 dots come up. But there is a reason for it. Okay? They don't want the system confused that you are trying to launch it versus you trying to move it. So, launch Visual Studio. First time you launch it, you get some pre-setup stuff. So I'm going to go with this. I'm going to ignore the corner. Okay. And I'm just going to make it a window because I'm a fan of windows, not full screeners. Okay. And I'll make it a little wider. Okay. So let's just go through what you can do. Yeah. Open your Udev playground? No, I don't want to do that. Split editor? Nah. Mark done. Track your code. No, we're not going to do a repo. Customize your shortcuts. There's only one keyboard shortcut we care about in here, and that is file save, which they've already done in this version, which is nice. It used to be this wasn't set. But in CircuitPython, as you remember, saving the file runs the file basically from the CircuitPython device. So being able to do a hotkey Control S just to save things, you want to check things out, that's important. And we're marked done. Okay, so that was actually, I believe, new with 1.58, this little front tutorial. It didn't exist in 1.57. Okay, so this is empty. Now on your left side, you've got a bunch of these icons. Top one is the file, bottom one is the extensions. Okay, if we look at extensions, we look at installed, 0. We have nothing. Now, of course, you can see that Microsoft lists the top 3 things they think you should be in. Well, maybe down here, 4th one. Python, C++, Jupyter, and C#. Oh, look at that. They even offered me to have Vim within the editor. No, I'll keep my Vim to my Vim. Right? But since we're doing CircuitPython, we have to get a base done. So first thing to first is Python. Now, one thing you can also do on here, if you search Python, notice there's 60 billion Python things. Okay? Now, what happens here is this is the root. This is the Microsoft stuff. Okay? Now, last time I did the install of this, it was just Python. But we're going to check what else it might install along with it. Because sometimes these packages, you can consider them meta packages. They actually contain more than one. So, for example, this Python extension pack down here, it installs all these things. Python, Visual Studio IntelliCode, Django, Jinja, Magic Python. Right? So what we want to do is go into this one, and we're going to install this one and see what happens. It should, in theory, put Python in. It might put a few extra in. So off it goes to the races. You can see the little blue scroll up there. It's busy working on it. It's installed. There we go. Done. So we'll take out of our search expression because we want to see install. I was correct. They've changed this a little bit. So they've added Jupyter Notebooks. They've added Pylance. They've added Python. Okay. Now, one of the things in here, we want to make sure we can install this actually just extra to make sure it works. So there is a popular thing here and a recommended thing here, right? We'll just click it off. So what we can do here, see there's Visual Studio IntelliCode, and there is a Pylance in here, but they already put Pylance in here. See? But I don't see IntelliCode in here. So let's go Visual IntelliCode. Okay. We're going to put that one in. Now the other one is Sense. I think it's something like that. No. Used to be two of them. Sense. No, won't worry about it. I remember on my other VM, but I did this a while back. I had in Visual Studio IntelliSense also, but maybe they finally have integrated the IntelliSense component into the language component. Okay, so now we have those two installed. We're not quite done yet with the extensions. Okay. Let's just go make sure Python. Yeah, okay. Itchy nose. Okay. So you got all that parts in, but we're still not at CircuitPython's level yet. We just want to make sure everything is in and is running. Now, one thing I do recommend is you do major extension installs like this. It's just exit Visual Studio Code, count 3 elephants, and start it again. Sometimes when you do stuff like this, it insists on a restart, but it doesn't really tell you this. And you find you got weird things happening. Usually the best thing is just to restart Visual Studio Code. So we have nothing yet. We can do a Python file. So we can go here and say new file, for example. Okay. Now, I'm going to get rid of the icon. I'm going to go here and let us open a folder. Let us open the work directory. Yes, I trust the author. This is new too. Of course, the author is me. Okay. Now, it just so happens inside of work I have this. This is not the way I would organize my work, by the way. Okay. But we're just going to demonstrate that the Python works. So, new file. Come on, give me a new file. There we go. Test.py. Print. So you can see, oh yes, you want to really, really help me. Print. So you can see we got our IntelliSense, we got our IntelliCode. It's out prompting with stuff. Our classic, right? And there's a big fat green button over here. You could say run Python in the terminal. Hello world, blah. Python's working. Okay, that's all we want to know. We're ready to go next step. So we go back to here. And we know we have Pylance installed because we can see it in our installed stuff. Jupyter Pylance. Okay, Pylance is Microsoft's idea of the language engine. It's also a linting program and a bunch of other stuff like that. It's also the most pain in the ass thing to work with. Now, there are two main language servers that you can implement with Python. Jedi or Pylance. The other thing is once you start doing some Python code, you can see this down here. You're going to have the interpreter where you can pick the interpreter. So in this case, down here we have Python 3.8.10, 64-bit. It knows we're running that. No problems. Okay, this will come out here as under the problem window. We also have down here tweet feedback and notifications. Okay, you can see right now we're in a Python shell basically. Well, a shell running Python. Okay, that's what that play button did up there. So in our extensions, we are going to now install, and this should be the correct order, CircuitPython. There we go. So this is Joe DeVio's, I hope I say his name wrong, but I probably did. His CircuitPython app. Now, the real function of this extension is to complete some of the code sense inside of CircuitPython. We'll install it. It's going to do a number of things for us. Not only will it go and get a copy of the thing, I believe he stated in his GitHub that he uses Azure Cloud and some weird tools over there to actually build this extension for Visual Studio Code. But there we go, it's installed. Now, as I said, major things, just exit and come back in again. Now, I'm not going to show the welcome screen anymore, so I'm going to turn it off in here. And in this case, we don't want to see that folder actually anymore either. We're going to be a little more proper about this. Close folder. So we're empty. Now we're going to set ourselves up for this Pico right here. And to do that, we want to basically work in a subdirectory. How's that one? So now we have a Pico. We don't need our test file anymore. Gone. Ta-da. Okay. So one of the things we're going to find out right away, and hopefully this will be, Murphy's Law won't screw me around on this. Okay, we're going to plug this in. So, do we have the device or not? Let's find out in devices. Removable devices. Adafruit Pico. Yes, it is in here. So we should have this device. And we're going to just check here. Our friend dmessage. There is our Pico right there. Raspberry Pi Pico. Yada, yada, yada. Now, I noticed this slight change in the KD Neon prompter. Normally there's an icon in here, USB devices and disks. And I'm noticing lately it wasn't actually popping up and saying offer to mount in whatever. What I have noticed though, I go down here into the File Explorer, there's CircuitPython right there. And if I click on it, voila, it's now mounted. Now, I've pre-prepped this Pico with CircuitPython and the classic Blink program. That's all I've done on it. Okay. Now, normally, when you first take one of these things as Virgin, there are two subdirectories that are not in there. The VS Code, of course, and the Pico Code Workspace. They don't exist in here. Okay. Now, you'll notice that there's some other directories in here. I wonder if I can zoom. Yeah, I can zoom it a bit. Okay. Some of these other directories in here, this FVSN vent SD, the trashes, the metadata never index. Some of these deal with environments, not Linux, but Mac. So apparently, if you don't want the Mac to do stupid things on the limited space that's on here, you create one of these directories. And it stops this from happening. I think there's yeah. This is a dummy folder, apparently, holding a dummy file, and this is telling the Mac, I think, don't do this. Don't index this drive. This guy here is the trashes from the Linux side. I'm not sure if you're aware, Linux is trying to be more Windowsy and gives you a retrievable junk directory. Like, I mean, if you trash something now from the GUI, it goes into the trashes and you can restore it again. In classical Unix, if you delete something, sorry, buddy, it's gone. That's always been the way for a long time, but no, people weren't happy with that. Okay. And then there will be an empty code file in here, basically with hello world in it. Okay. That is the stock CircuitPython install onto the Pico. That's usually all it contains. Since I've already loaded this into Visual Studio Code once and I saved it out, I have a VS Code directory and a PyPico code workspace. Now, to achieve creation of this, what you're going to do is in your file explorer here, you're going to open a folder. You're going to open the CircuitPython directory. Yes, I trust this directory. That can get tedious. Now, this is new. Before, I wouldn't say anything about this. So you can see now, it's figured out it's on CircuitPython, the CircuitPython extension. It's gone and get the code bundle, this, and it will do this every single time you load up one of these guys. The idea being is that it goes and retrieves the most current bundle from Adafruit, from the circuitpython.org hub. Make sure you're always up to date on libraries and stuff like this. Okay. Now, what you want to do in here is when you first open this up, these two guys are not here. Right? So you'll want to, first of all, when you open up, you save file, save workspace as, and give it a name for your workspace. I've already done this. Okay. And when you do that, this gets created. Now I'm going to close this folder off and open up the actual workspace folder in there. So this time I'm going to open a workspace. I'll go to CircuitPy. I will pick this workspace and I will open it up. Okay. See again, Mr. Bundle gets checked. Okay. So let's look at this file that it created. Now, by default, this file, you will get asked the question in here, since I've already done it once. In fact, let's do something a little special here. File close. Let's close this workspace for a sec. I'm going to just get a copy of the contents of this. Okay, so we're going to go back to home, work, and we're going to make a new folder here, and we're going to call it Pico BU. Okay, and here, Control A, copy, and in here, paste 8 items, doink. Okay, now in here, and are we still open? Nope, good, we're closed. And here, we're going to go, and this guy here, and this guy here, we're just going to delete them. Okay, so I've added to my file explorer in KDE Dolphin, I turned on the option that when I chose to actually delete, it really deletes. So these files are all gone. Okay, nothing there. Okay, so this is usually what the stock will look like. Now let's we open this up again. File. This time we don't have a workspace file to open, so we'll open the folder. Okay, should be our check. We don't have a board. Doesn't know what it is. Doesn't know about anything. It's created the VS Code directory. It's created the initial settings JSON file, but we don't have a workspace file. So as I said, the first thing you should do before you do anything, file, save workspace as, and give it a name. We'll call it Pico 1. Why not, right? So now we have a Pico 1 workspace. If we open this file up, okay, it populates some of the stuff in here. Now, one thing I've noticed in here, and I don't know if this he has fixed this yet in the release version of his extension. I'm just going to widen this a little bit more. Notice there's a blank path in here. The other file had a null. Yeah, not a good idea. So you can see in here, some stuff are put in place by default. Now, it used to be, just a few versions back, the default was unchosen for the language server. You actually had to go F1 language, configure language server or something there. Restart language servers. It's in here somewhere, right? You would set the language server. Apparently you don't have to do that anymore, which is nice. And of course it's defaulting to Pylance. Okay. Now, one other thing in here, this is a JSON file. We will open the code up in here. Already we can see a problem. Notice the board, we can figure it out. This is the type of things I was having with Pylance. I was having with CircuitPython as a general, is imports were not being found properly. Okay. So we are going to fix this. But one of the things that is recommended in here is another extension. This is a more cosmetic extension. And that is MagicPython. MagicPython is a syntax highlighter, cutting edge Python 3, blah, blah, blah. All the usual fun stuff. Okay. So we're going to add this one too. That's it. Just this one. I don't think there's any other real. There's some other extensions you could do. A REPL. But I will get into an issue that I haven't solved yet with debugging. And I think this will require a fix from Adafruit themselves. I think this stems from the way things work on CircuitPython more than anything else. Now, as I said before, you do a change like this. In this case, since we just created the workspace, I would politely close the workspace and then restart this to make sure everything's active again. As I said, certain things, Visual Studio will install it, but it won't. Come on, guys. Can we not do that? There we go. So, File, Open Workspace again. I've never done a duplicate workspace, but who knows? CircuitPython, Code 1, Open. Okay. Checks the bundle. We haven't chosen a board yet, so let's choose a board. So we know this is a Pico. Raspberry Pi Pico. Okay. Now you see some line changes in the workspace. It's actually added the Picos. And to boot, you can see here, it's directly referencing the boards directory for the Pico. It's referencing the stubs directory. And if I slide this all the way over, and the bundle directory. Let's go check the code out this time. See what happens. Do we still have our board issue? So I think it's time we fix this. And just to make sure we're not interfering with anything over here, or this interferes with us. And you can also see in here, we've got a warning, 1. So we want to see warnings. We can click down here. The import board cannot be resolved. What did I say? Imports are an issue. So we're going to fix this now. I'm going to close this off. We'll get back here, but we're going to now work at the command line and fix this. Okay. Not the file explorer. There. Command line. Okay. So I'll call my fixing directory fix. Ah, yes. Very creative. So what we need, first of all, is the code for that extension from him. And I happen to have it ready right here. So this is the GitHub repository. This is where we're going to get it from. And all you do here in GitHub, you go here to code, and I flag it as HTTPS. Now, if you flag this, if you have the option for SSH, that assumes that you have an account over there. I'm not signed in here at the moment. I do have a GitHub. That's why I'm not being offered. So I will clone that. And in here, git clone paste. Doing. Okay, so we now have a copy of his extension. Time for some slurping. We go in here and we have a look. You see everything's in here. Except if we look at his installed version of it, and we're going to do that right now, ls minus la. And normally I can do $home, but I'm a long typer. That's where all your VS Code lies. That's all your extensions lie. And we are into Joe. That one. So you can see in this chunk, we have a whole bunch of other. That's what I'm talking about. The Azure pipeline, by the way. We have all this stuff. And in the installed version, we have all this stuff. Notice that we have a stubs directory and a boards directory here. But we don't have it yet here. We're going to build those. So if we go into scripts and have a look, we have some scripts. Now this extension is designed for both the Mac, the Linux, and Windows. So that's why we have a Windows style batch file. We also have a Unix style shell script. I'm pretty sure that this shell script runs also in the Mac, but it has a problem. If we look at this shell script right here, let's see if you can spot the error down here. If you spotted that they were not backing up a number of subdirectories properly, you spotted the problem. So what we want to do, we know that I've tested this out. We know that this works. CD CircuitPython, the 2 gits work. The pip3 install requirements works. The make stubs works. The move works. It's everything below this that's broken. So this is where our vim comes in effect. We want to modify this build script a little bit. So what I'm going to do in here, okay, we are going to actually execute some, and this last one, this is the real bad command. It shouldn't be doing this, because when you do this, it doesn't work properly in CircuitPython. And we'll talk a little bit the 2 different files that are called board. Okay. Okay. Now we're left with cat build scripts. We've remmed out everything up to the point after we've moved the stubs directory. Okay. Let's see if this works. Last time I tested it, it works at this point. So to execute a shell script like this, just like that, we go off and get the CircuitPython Git repo. We do all this. Okay, so we missed something here. Okay, I think I had this error before. So if we go into the CircuitPython directory, okay, and what should have happened in the script, we're going to fix the script. It didn't make the stubs directory properly. So our build script again. And after we clone and cd into here, we do all these submodules. Okay. Since we're in the CircuitPython, we're going to do a make stubs. Well, they have a make stubs there. So why did it not work? Okay. Something actually, whoops, is happened. This is where I had to do this step by step and find out what's going on. Q exclamation mark quits without changes. So something, it didn't make the stubs. Why did it not make the stubs? I don't see it here. That's the trick. So it did all this correctly. Unpacking objects from branch, submanual path, checked out. Build stuff that is line 7, pip 3, command not found. Okay, now we know what happened. Okay, we're missing 2 packages in our distro. Where is pip? Doesn't exist. So apt install pip 3. We don't have a pip 3 pip. Yes. I don't understand why, if you're going to install Python into your thing, why on earth you don't put pip in? It's like the root of all evil. Now we need to actually upgrade pip. So we're going to just do a quick search here, because I don't remember this off by heart all the time. Update pip. So what we want to do, we need to update the pip. Now, self-updating. Pip can be actually updated. Pip package in Linux. So it's basically this right here is what we're actually at. So go here, and our package name is pip. See, we updated pip from pip. Okay, now pip is there. Now the other one, we didn't have make, and I forgot completely about that. So apt install build essentials. Okay, build essentials is in. Does that mean we have a make? Oh, sorry. Where is... We have a make. Okay, good. We've been corrected. So, doink, doink, doink. There we go. So, we'll start this off again. In this case, rm-rf CircuitPython. We'll just start all over again. And try one more time. Try number 2 at this. I forgot completely about those 2 tools. Okay. Cloning. Cloning. Requirements file. That was in the script. Means pip was working. Stubs. Stubs was working. We now have a stubs directory. Now this is the part we have to do manually. Cat the build again, because we need to look at. Okay, so he would have us back one directory after making the stubs and moving the stubs, and then he would have us install another requirements file. So pip install -r Okay, cd back into scripts again. We completed that stage. Now they would have us run the build stubs Python file. Python 3, except we're not doing that path because technically when we backed out of the CircuitPython directory, we are in the scripts directory. So doing this doesn't work. In fact, doing this doesn't work either. We had to actually go back to subdirectories. So in our case, we need to run. So now if we look, this is building that boards tree. We now have boards. We have stubs. In fact, it's actually up to date because it's based on whatever the current GitHub repo for the whole CircuitPython system. Now that we have these in here, if we look at the last line of our thing, they would have us remove this. And I say, no, don't do it. Let's have a look at what they're actually looking at. There's a subdirectory in here called board. That's missing in his. If we go ls minus, we won't do an LA. Home, Willem, .vs code, extensions, Joe, and we are looking in stubs. Board is missing in here. Not good. If we look into that particular directory and we look into, cd stubs boards, we're going to see one of the two types of file this is in. This guy. This is known as a stub file for Python. It wraps around, my guess is the actual C code, and exposes everything to the system. You can have a look in it. It's not like it's hidden or anything like that. What this does is it defines some stuff for dealing with the pins on the board. That's really all the board files actually do. Now, in the boards directory, do an ls, we have this one, board.pyi. We cat this board.py. What we have here is a filler file, a template. And in fact, it's based on, I guess, the microbit v2, but it really is, it's a template for what to do with everything. Okay. And of course, if we go there, that one, and we go and look in boards. This case, it looks like he's fixed it. We can actually have a check at that. Let's go cat. Okay. He does. Now, what we don't know is what I've built is at the same level what already existed. Since I'm building based off current stuff for today, we need to make sure that if we drop and place these two directories, that we're matching for everything. So, in this case, we are going to go off into .vs code, extensions, Joe, and we're going to move boards to .org. We're going to move stubs.org. Like so they're out of the way. I have a tendency to back things up first, not just blindly erase things. Right? So this is where Midnight Commander comes in effect. If you ever, you have to be old as me to remember DOS days. And Norton Commander was a very popular utility back in the 80s. When you had to copy lots of files on your hard drive, it gave you this double paned effect, left and right. Later tools like WinSCP and stuff like that basically are variants on the Norton Commander theme. So we have our destination and our source at the moment are the same. We just tab back and forth. So I'm going to back up and I'm going to go into the work directory and I'm going to go into the fix and I'm going to go into here and I'm going to go into scripts. And I'm going to go Control T, pick boards, Control T, pick stubs, F5, and I'm going to copy them over. Yes, modern hardware makes it like blinkety blink fast. SSDs make it blinkety blink blink fast. Yes. Actually, 2 NVMe's in here makes it blinkety blinkety blinky fast. You can't tell how fast. Anyway, I've now changed this. So if we look here, boards and stubs, they are replaced with our rebuilt versions of it. So let's go back to Visual Studio Code. Open the workspace. Oh, look, no problems. We highlight board. Look at that. Fixed. Working correctly. Visual I/O. Working correctly. Time. That's a base system Python file. Now, if you choose to add more Python modules to your OS's Python, there is now a golden rule about this. Don't do it globally. Do it as the user. And in fact, they highly recommend you go one step finer and you do it as a virtual environment. The idea being you create the virtual environment, and in the virtual environment, when you join it, you then add on all the parts you want to work with. Okay. Golden rule number 2, do not screw this up. Do not install Adafruit stuff for the OS's version of Python. They're not the same. So yes, there's an Adafruit Blinka and a bunch of Adafruit stuff. Now, when you're working with all this stuff, your friend is the PyPy repo. Okay, the package indexer. If you actually search projects in here, Adafruit, there is a ton of Adafruit in here. In fact, everything that you see in the CircuitPython libraries directory is here. Now, if you want a better understanding of all this and how to load your board up with libraries, this is not the way to do it. This is intended for people who are on a Raspberry Pi and are using its GPIO pins to control things with CircuitPython. In that case, not this Pico, but let's say a Raspberry Pi Zero or a Raspberry Pi regular, those ones. Then you would go here because in essence, the machine is also the CircuitPython drive, right? These guys, these little boards like this, it's a separate, isolated little environment on the board. It's not technically like the Raspberry Pi regular. We have all this other stuff that's running, the OS, everything else. Okay? So putting this into your local Python stuff can affect the way you code on these little boards. Because then CircuitPython gets confused. It looks for stuff on the board. It also finds stuff in your OS. And sometimes it'll work. And sometimes it will not work. And not work in a subtle and nasty way. And you can't figure out why the code is not working. So this is not for these little boards. So instead, what we want to do, we go visit the libraries page on CircuitPython. And you're going to find here bundle versions. Now, my understanding is 7 is not production yet. It's at the tail end of testing. But what we're going to do is we're going to download the bundle, the MPY files, and we're going to talk a little bit about MPYs. And in this case, I'm going to actually put these in my work directory, and I'm going to actually create a subfolder here, and I'm just going to call it Adafruit. Okay, and we'll save it in here. And for the hell of it, we'll take the 7x bundle because we're greedy and we want all the files we can get. I will also take the Pi version, and I'll take the examples file. So if you're looking at their 2,500 plus tutorials on Adafruit, and yeah, there's a lot of them, these examples will contain every one of them. They might not contain the notes complete about it, but they will contain all the code. Okay, this is also a place you can see. So for example, today is the 25th, and you can see on the 25th, these things have been done to it. So there was updates. So this is why the extension goes and checks for that bundle and continuously gets a new fresh version every day or every time you want to load up. Okay, so we've downloaded them, and we'll go and look at our CD work, and we see we have our Adafruit tree. CD Adafruit. Okay. Now, one thing, when I ever get a tar file or a zip file, tar file being tar or compressed tar, TGZ, or tar.gz, you want to check, did they actually put the subdirectory in there and then the files, or did they just put the files in there? I've encountered both. So one way to test this guy out is -t, and I'm just going to check the MPY bundle file. Just check it out. Okay, we can see here they created the subdirectory. So we can go back up, take our T off. Ta-da. And since we want, I'm not going to unpack the 7, but I am going to unpack this. And I am going to unpack the examples. So basically, we've unpacked 3 of the 4 files. I'm not going to worry about 7. So when you're working in this case of the Blink program, there is nothing to load. If you look, my library directory is empty. Now we come upon a case of another import issue. And we want to put something in here. Let's go look at the examples. Let's see something where we need to put some libraries in, and we'll create some code. I'm going to want Mr. Walk and Adafruit, and now we want the examples. There we go. So if you look in examples, wow, whole pile of examples. Okay. And some of them are, you can see by the names of some of them, they're around certain boards and stuff like that. This guy here is a lot of LED. Can we find something fairly simple in here? I don't have a GPS on there. Does this thing have the, can't remember if the Pico had the, what's it called? The 3-axis sensor in there. I wonder if that's in here. Actually, let's just take the Max 72 simple test. I'm going to borrow this file, And I'm going to go back to here to CircuitPython. I'm going to paste it in here. Okay, like so. And we'll go back to CircuitPython because we know we're going to need a library out of this. Okay, and I'm going to rename code.py because in CircuitPython, you can only have one code.py. It's like Lord of the Rings. You can only have one ring to rule them all. So in this case, we can only have one code file rule them all. We'll just call it code1.py. We'll get it out of the way. And we're going to rename this guy here as code.py. Okay, so we look at this. We have to import the Mac 7219. We need that. Now, there's a good chance this code will not do a damn thing at the moment. Even though it thinks it's there, it probably isn't there. We don't have that in the lib directory. Okay. So if we go file exploring, we need to put in the code. So that was our examples directory. And get rid of it. And we go to the bundle directory. Now, the reason they give you MPY and they give you pi, they're effectively the same thing, except MPY is like a compiled bitwise thingy, uses less space up on your device. The idea is that you don't waste space because space can be precious. So if we look in here, we just see under the Adafruits, there's the max right there. Copy. And we go around the CircuitPy and we go into lib and we paste one folder. Okay. Now, to ensure that we're actually doing things correctly, we're going to officially close this workspace and open it again. Close workspace and open workspace again. If we look in the lib for, well, that's interesting. That's a different way of doing it. Normally I expect a subdirectory and I would open the sub. But you see here, there is really some stuff here compressed and an init file for it. And you cannot peek into these. These are compressed files. If you want to be able to peek into these files, you have to go and install the Pi file. But in theory, if we click on this and we say go to reference, I think it is go to reference. Go to the declaration. Nope. See, it's a wrapper. Doesn't work very well. If you put the Pi version subdirectory in here and you did that, you'd actually get the code from Mac 72.9, this file here. Right? I don't think we can get anything out of matrices either. Go to declaration. Nope, we can't. Okay. And they're already complaining about this. But I wouldn't worry about it. I think this is a false red herring. This is where we need to do another tweak to our workspace. We want to add a file in here to tell Pylance to stop being an idiot and overdoing things. So that's what we're going to do next. But as you can see, the environment is working really, really well. We've fixed our import problem, basically. We have main code.py working. We can drop stuff into the library directly. It's finding things correctly. We can look at the settings.json file. Now, This one is a very short one. Let's go look at the one I created for this. I extended this file a little bit. I think I extended this file a little bit. So I'm just going to go look at it. Remember, we saved everything in the backup. Aha, you're saying. That's a good idea. Why did I not think of it? So I'm just going to open this up. And yes, you can see this is slightly different. Okay. It's basically over everything else is exactly the same, but we have a couple more extra lines in here. Okay. So I'm going to just borrow this code. I know we're going to generate an error, but I just want to compare the two sets of code, basically. Go away, go down here. So the original code, as you can see, the top chunk is basically the same. We have analyze extra paths, right? And we only have two paths in here, stubs and the bundle. In mine, I've included stubs. I've included a piece from his global storage, which is 2021-07-20. That. And technically, this lower one here is not needed. I'm actually going to remove it. Now, this is all JSON files, so if you do something like this, you have to remove the last comma like that. It lives for the comma, okay? So we can see, I've added boards into here to make sure it finds stuff in the boards directory correctly. And otherwise, I'm basically identical. In fact, it looks like, what's the version up here? 114? Yeah. I've doubled up on one here. Normally these things are, that particular line is done auto-magically by him. But we do know, like so. So we have stubs, we have that line, everything else is identical. So the only real other line I add in is this one right here. So I'm going to borrow that line. And we'll just go up here. And we'll put a comma on it. And then this chunk of code down here, which JSON is bitterly complaining about because I didn't do nesting and stuff like that correctly. This is where the Control S comes in. There we go. So that's that one. And this is this one. Okay. Now we have to deal with Mr. Pylance being an idiot. So let's deal with Pylance being an idiot. And I happen to have an idiot control file for Pylance. Whoops. That's not what I want. Wrong Pylance. Okay. So if we go into my, I don't think I have it in here. No. If we go into my Metro M4 Express, which is I copied over, we have a pylint RC file. Copy. And you can get a template of this file a number of places. I got mine from, I think, the Pylance Git or whatever, just to get a sample of the Pylance file. And, oops, we need to go back to here. We need to jump up back to CircuitPy, and we need to paste this here. Pylance RC. Okay. Oops. Of course, I keep forgetting. In Visual Studio Code, F5 is not refresh the screen. F5 is run code. Okay. So let's open this Pylance directory. So what this really is, it's all the parameters and control systems for Pylance. And the only thing we really care about in here is this. This is controlling the error codes that Pylance will nag the hell out of you for. And basically what I've done is from about here, really dumb ones that we know we're doing this. bad white spaces, trailing white spaces, bad indentation, pointless string, reporting missing imports, line too long. Line too long is a very annoying one, right? If you come from another language like C, yeah, you can have a line as technically C is one big long line once the compiler gets done with it. So we do that. And then this bottom piece here, we can see we're doing a little, it's kind of broken at the moment because it doesn't update manually. It doesn't really affect the system. But you see all those 111s and dates in there? They're all wrong at the moment. It's not really that important. You can go in here and fix it if you want. I can make this, 114. Fix the board. The usual stuff like this, right? But I'll save that. I'm not worried about that. If you put that in, this buffer block is what you care about. It cuts down on, it cuts down on errors showing up in here that are kind of dumb. So it's a good idea. Another thing you'll find in CircuitPython, the order of the imports is important. Sometimes you'll put demo code in there and it'll complain. So what you do is you go here and you sort imports. There you go. We just sorted the imports. It doesn't like board where it was. Yeah. Okay. Okay. So now we've solved linting issues. We've solved import issues. And everything is working clean. And we promise not to screw it up. Well, I hope I won't screw it up. At this point, you're ready to go. You should be having a clean working thing. Now, one thing you'll find, if you get a bleeding edge new board down here, it might not be in here. You might click this and get an error message because it can't find it. Okay? I know a bug was submitted about that, and there was supposed to be a generic filler was supposed to be provided to fill that area up. But all that really does down here is add to the workspace these lines down here. So once you've done one of these boards and you've got the vendor ID, product ID, you can tweak these two set of lines, this set one and these two with the correct one. Now you will notice that Adafruit is always one particular one, right? And Raspberry is another particular vendor code, that sort of thing. So you'll find if you go, I think, to 23.9a in the boards directory, you'll find a whole whackload of product IDs. Okay? But that's all you have to change. And after this, you rarely go into these files. You don't touch anything. One other thing I have found that'll drive you nuts, and that's my job, is to make sure you go nuts, is paths. You're wondering, well, what about them? Now, in theory, in these extra paths, if you put a trailing slash on here, it's supposed to be everything under that directory. Doesn't always work. I am 50-50 on this. So sometimes I'll have to modify these paths specifically. Like if I said in here, just, for example, if I put in this blank path, which is not a null, luckily, if I put in here, /media/willam/CircuitPython/, you would think I wouldn't need anything else to find all the stuff in the CircuitPython directory. Doesn't work. I literally have to specify /lib, for example, for it to find stuff in the lib directory. Well, great. Okay. So watch out for that. And I don't know if that is a damn Pylance problem again or not. Yeah, you think, well, you're having all these Pylance issues, you might as well shoot it in the foot and get rid of it and go to Jedi. Well, Jedi's older. Pylance is newer. It's the one that seems Microsoft's actively maintaining. Now, let us open a different workspace. I'm going to put a different board on. Close Workspace. And I'm going to go to the File Explorer here and safely remove. Oh, this is key. You want to stop corrupting your device and forcing you to have to put the UF2 BIOS firmware back on all the time. Don't pull the board without doing a safe remove. Okay. So I've safely shut it down and I will remove it. Don't do that. So I have here the M4 Metro plus the LED matrix I was working on. I'm not going to do really any coding on it, but I just want to show. We plug it in. So it's told us, and by the way, here's that alien, not working quite right, timing's off, but we click on our CircuitPython down here, and it's mounted. And we come back in here, we'll open that workspace and have a look at it. As you should see, open workspace, CircuitPython. We should see a code check to make sure that our bundle is up to date. There it goes. Okay. We see down here an Adafruit Industries Metro Express M4 serial connector. If we click on code, there was all the code. Linter PyLint is not installed. Okay. We missed one. I will install it. Oh, I made an error. PyLint RC is for that tool. It's not for Pylance. But they kind of work together. So you can see down here that it's putting it in as a local install for the user, not a global install, which is what we want. Okay. So we missed one extension, and it's complaining that we have 3 problems. Okay, so board cannot be resolved, bus cannot be resolved, digital I/O cannot be resolved. Now this is where this is the type of issues I was having before. Now let's just exit this, and I'm going to just start it again, just to make sure that because of the PyLint install, we didn't screw it up. All the trailing new lines. Now, why would this one not have board? I fixed everything. Well, it's possible the VS Code settings JSON is off. And it is. So that's where our problem is. 14, 14. And 0716? No. I believe that's 0725. We can check for that. Sometimes I find this does not update. Joe's thing doesn't update things. So you have to kind of sometimes make sure it does. So we'll just look at home, and we'll look at .vs code extensions. Joe. Yeah, 14. Okay. And then we have in its global storage It's somewhere in here. I think it's global storage. We want to find, oh, config code user. Okay. Not in here, not in here. We want, oops, I'm missing a directory somewhere. Where is it? .config. Okay. Completely out of this tree. .config. And then it is code. Right. There we go. Down this tree, global. It's in here somewhere. Oh, user. Global storage. Joe. Bundle. What's our bundle? Yeah, 725. Okay, so we're fine. So we correct these. Subs, boards, 725. This 716 should be 25. Like so. Control S on that. And then we need to also fix the metro file too. It's probably wrong. Yeah, that's what I thought. 14. And that got updated. That's good. Control. Oh, this is something I had to turn on when I was working on this particular board. The RAM size in the Metro 4 is smaller than the Pico, for example. Make sure Python linting MPYs enabled is false. Otherwise, you'll fill the drive up. Just like that. Also, this could be 6.2, 6.2, like so. And Control S. Now, I happen to have an extra path in mind. I was experimenting. That's the stub path parameter for Pylance. It only accepts one path. I just wanted to make sure it was finding the stubs. I probably don't need it. Right? The extra paths is probably, analysis extra path is probably fine. So we get rid of this. We get rid of this. And we go back to code. Voila. Fixed. So beware of that. Sometimes if you load an old project up and you're getting this, it's just probably the paths and settings are dated and you might have to update them. But in this lib directory, for example, I have all these ones for messing around on this board with RGB LED things that I was working on. And I think on this one, I can't remember. Yeah. So this one is correct in the sense that it actually expands it all out. But there you go. This is the board file that you remember. Now, of course, it's complaining about an import here. This is really a case of bootstrapping itself. It's complaining that you can't do, unable to import bus IO, but in reality, it's incorrect. I wish some of this stuff wasn't recursive. So what else we got in here? Bus IO. Go to declaration. Yeah, so again, you get this sort of stuff in here. But everything will work just fine. This is, I think, a Pylance error more than anything else than actually being the code being wrong. Right? So your mileage will vary a little bit. But this is how you kind of troubleshoot things. I found when I was playing with this, with the Macs, that's why you see the fonts file down here. I had to put the fonts file in the root. I couldn't leave it in the lib. Even though technically in the lib, that's where the fonts files first showed up. It didn't like it there. And yeah, this is where this trash can might actually have stuff in it. Well, maybe not today. I cleaned it out again. So watch out for that. And why is there a README down here? What does that say? Welcome to CircuitPython. Oh, okay. Your Metro M4 with CircuitPython? No, this is not a Metro M4. This is a Metro M0. This is an M4. But it is working. We have loaded it on. Okay, new lines. See this? Trailing new lines. Who cares? I have an extra trailing new line. We have trailing white spaces, so let's just go here and say trailing new lines, comma. Oh, we don't have a lint problem anymore. That's how you get rid of the damn things. I mean, really, so what? I have 2 lines down here. It's not going to kill the damn Python file. Right? I'm sorry, but this is where I think Python, in a sense, gets way too finicky about things. Yes, I understand the need. I heard that Rust is even finickier. You have to do things exactly a certain way. Yes, I understand it's probably going to prevent errors and whatever, but I don't think having an extra new line at the bottom of your file is going to cause a security risk and blah, blah, blah. I think they go overboard. So, and of course, in this Pylant file, as you see, basically the same one. But I think I've got everything covered. And if you have any questions about any of this, this is all done from scratch, done from square one. This should get you CircuitPython installed, build environment working, IntelliSense working, couple of problems fixed, errors in the, not errors, more like annoyances in the PyLint, fixes in the PyLance to solve some stupid pathing issues that it always has, and of course, fixing the CircuitPython extension itself. So the primary error was board not being imported, which is now completely solved. Now there's one last thing I do not have a solution for. What if you want to debug this? Well, at the moment, I am forced to do things like this, prints. You would think that I can, yes, I can go to the repo. There you go. Let's see if I can actually stop this code. I think I might not be passing my control C's through. That's one problem with a VM. Let me just check. Is VM... yeah, I might not be actually passing control C. Let me just check with the console prompt here for a sec. No, I am passing a control C. It's this guy is not. One other thing we have to talk about. Now I remember why. See this stupid error message? Okay. In this case, I need to go back to my console. And I happen to have this virtual machine open in a console window here. Okay. Now we need to fix something I completely forgot about. This is outside of CircuitPython or anything. It has simply to do with when you're dealing with boards like this, Arduino, or anything like this, you're not allowed. So I am going to, in the VM, su dash root, and yes, the very secure password. If we go into etc udev, okay, rules, we have no rules to handle all these boards. If I go over to the host system, etc udev rules, and this you can't see at the moment because I am not putting the console up, but I will now put it up. Okay. Not rules. We have a bunch of rules. So we want these rules, except for the snap chromium rules. Actually, I do not need those anymore. RMSRF. Let's get rid of those. If you're wondering how I'm doing this, okay, it's classic Unix, middle mouse button, paste whatever you last highlighted. So we don't need those. But we want all the other rules. Okay? We technically don't need the VMware SCSI Udev rules. That's the one for the host system. We'll copy it, but we'll remove it because we don't really need it. Technically, the Handtech is for the oscilloscope. We don't really need it in the VM. But anyway, let's move these rules. So SCP star to root at 192.168.42.213 etc udev rules.d. Oops, that's not going to work. Are you sure? 1, 2, 3, 4, 5, 6. See if that works. Oh. Something when you install by default into your guest OS on the VM. Let me go back to the VM here. And we'll just park this for a sec. SSH doesn't allow for direct root access. But being nasty people we are, get rid of that. We're going to fix that by etc sshd_config. We scroll down a little bit into here. This guy right here. X. And then we go over to here. Get rid of, append, and make it a yes. And then system control. That's if I spell system correctly. System control restart SSHD. Boing, like so. Now we'll go back to our console over here. Okay, we might have to just redo the connection again. So we've now transferred. Why did we go black? Okay. Console properties. Now we're going gray. That was funky. Okay. We've copied everything. All those rules now. We don't need this guy anymore. Let's go back to the VM player. And we're just going to clean up a little bit on this. So, ls minus la. Oops. Wrong directory. Okay, cd into etc udev rules dls. There we go. All our rules. And as I said before, I can get rid of them if I really want to, but I don't need. The ST-Linker programming devices, TTY USB controls all the USB ports. In fact, that's a kind of a cool rule to look at. If you want to know, it handles all forms of the TTYS port. USB, ACM, and S, whatever. And this square bracket stuff here just tells it could be 0 through 9. Blah, blah, blah. A little wildcarding, a little bit of symbol linking, blah, blah, blah group, mode. Yes, the devil. 666, which is read, write, read, write, read, write. Okay? So then we have the libsigrock for the signal acquisition device. Stock, the flirk is another. And the J-Link is another programmer. Platform IO, That got generated by Platformer, which we haven't done an install in here yet. I won't, but we will. I might do another install and talk through of that one. Okay, the VMware SCSI Udev rules. RM minus RF. We actually don't need this one. Actually, we'll just leave it in. It doesn't hurt. It doesn't do anything at all. Okay? So we don't worry about it. Now, if we go back over to here and we just exit and come back in. Okay. And we go down here and we try to open the serial monitor. Ooh, we're still denied. That's not correct. Did I put the rules in the right directory? Let's just close this off again. ifconfig. I'm pretty sure I put it in 213. Yes. Oh, almost forgot. Udev admin dash help for a sec. We need to trigger it. Okay. Let's try again. Oh, we don't need a second set. Come on, give me a break. Let us try opening again. Haha! This time it works. So we are in the repo. See? You know you're in Python because if you do this, and you do this, and you go this, and you go this, and you go this, Python, right? And then you go Control D and you restart it again and the board starts blinking again. Now, in theory, what you should be able to do is run start debugging. And it'll ask you current active Python file. And this is the problem I run into. I cannot seem to get around this. I mean, yes, all the stuff comes in. Doink, doink, doink. Class variables, special variables, function variables. All the beautiful stuff you expect from a good debugger. Except I have a problem with board. Now, this is the error. You'll get the error from... Where's the output for this error? There's a message behind this. It's not that there's no name board. Is that it likes to come back and think your board is your host system. In this case, it's actually the VM. If I did this on the host system, it would come back. You're on an Intel generic Linux board. I can't figure you out, right? No, I'm not. I'm on that Metro. And this is what I don't understand. I would love it if the debugger could just, jump over this and ignore it. But instead you get crap. And there's nothing much I can do about this at the moment. I haven't figured a way around this. I really, really wish that Adafruit would look at the CircuitPython with allowing the debugger to work properly. And I'm apparently not the only one, and other people have had this. So, who knows? No module found board, which is dumb because board is there. We know because it's there. And we know where it is, exactly, but it's not finding it. So that is the only thing I cannot give you in this tutorial is the debugger. So our result is, let's see, we'll run without debugging. No, running without debugging. Cut it out. Let's go back and this. So we are left with print statements. So this is why you see some stuff in here where I print out certain things, trying to figure out what's going on. So let's see. Okay, I'm going to leave it at this. I think I am going to turn basically this tutorial. I'm going to try and see if I can figure out how to do it. Not that I can't figure out how to do it. It probably would be time consuming, is to actually screenshot, cut and paste sections of this as I go through it, and create a PDF, so to speak, of a tutorial, maybe some a web page of it to put somewhere showing how to do all this. But this should get you started, and it should get you programming in CircuitPython. I might do an Atom one too. I have gotten Atom fully working, and they have their own version of CircuitPython extension for it. So I might choose to also do an Atom layout. A lot of the fundamental base stuff for the Python that is exactly the same. It's just in Atom, it has a definite different look and feel to what Visual Studio Code does. So we'll leave this at this moment. I'm just going to, of course, close my workspace. Actually, do I have anything to save? No, I don't. Okay, close workspace. We close that off. And that is it. I'm going to go and cut this video at the moment. If you like it, you know, do the stupid YouTube thing, like dislike, bitch, complain, whatever you want. Make comments, whatever you want. I'm still looking for, yes, 24 more subscribers. Maybe I can get to 100 one day. Yes, 10 years down the road, William finally gets 100 subscribers on his petty little channel. Well, who knows? So, bye-bye.